Betelgeuse, an enormous red supergiant located in the Orion constellation, has enchanted people for centuries with its palpable crimson glow and enormous size. Astronomers have estimated that if Betelgeuse were to be situated at the heart of our solar system, it would devour every planet up to Jupiter. This star's vastness signifies it is nearing the final phase in the life cycle of stars like it, preparing for a disastrous end-result explosion known as a supernova. In recent years, however, Betelgeuse has exhibited extraordinarily unusual behavior. Its luminosity surged by more than 50%, catapulting it from the 10th to the 7th most brilliant star in the sky. This unexpected flare of brightness led scientists to scramble for answers. Was this an early warning of its explosive demise or merely a temporary blip in its life cycle? The resulting effects are immense. If Betelgeuse were to go supernova, it could brighten the night sky to the point where it would rotate day and night, creating exceptional scientific opportunities. A star's brightness is influenced by its size, temperature, and proximity to Earth. Betelgeuse, with a radius more than 700 times that of the Sun, is relatively cooler, with temperatures at the surface of 3,000 Kelvin, which is what gives it its red color. Its size and low temperature make it a prime candidate for a supernova, making its behavior all the more intriguing. In late 2019, Betelgeuse stunned astronomers again by dimming to just 40% of its typical brightness. This dramatic change, visible without the use of telescopes, sparked widespread discussions and observations. Some speculated that dust might have obscured the star, while others considered internal processes. The possibility of a supernova occurring soon became a key topic among experts. Using Chile's Very Large Telescope, VLT, astronomers managed to capture detailed images of Betelgeuse during its dimming phase. These images revealed that the star had taken on a noticeably lopsided appearance, suggesting additional investigation that this dimming was probably brought on by a massive surface mass ejection, where Betelgeuse expelled an extraordinary quantity of material into space. This unprecedented event altered the star's appearance and disrupted its pulsation cycle. The event was comparable to a cosmic-scale eruption of volcanic activity, as Betelgeuse spit out more than 400 billion tons of material, much more than usual solar events. This upheaval not only changed the star's look, but also shortened its expansion period from 400 days to just 200. These major changes indicated that Betelgeuse is becoming more unstable, leading to more questions. How much longer can it keep its current form? Because of its erratic behavior, astronomers have ramped up their monitoring efforts, eagerly searching for signs of its impending collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core collapses under the weight of its own gravity, triggering a supernova. This colossal explosion releases an immense amount of energy, blasting the outer layers of the star into space and creating a dazzling light show visible even during daylight hours. If Betelgeuse bursts into flames, the first signal would be a burst of neutrinos, tiny subatomic particles that travel faster than light and are able to escape the star. These neutrinos would reach Earth hours prior to the explosion's light itself. Once the light does arrive, Betelgeuse could shine brighter than the full moon, casting eerie shadows and illuminating the night sky for weeks. A supernova with this much power would present an unprecedented opportunity for scientists to study stellar death in real time. By analyzing the light emitted, researchers could study heat and radiation, gathering invaluable information about stellar evolution, nuclear physics, and the formation of elements essential for life. To understand Betelgeuse's unusual behavior, researchers are using sophisticated star model simulations. These simulated models include information from telescopes like the James Webb Space Telescope, JWST, and the VLT, allowing researchers to delve into the mechanisms that underpin Betelgeuse's instability. As demonstrated by these simulations, a significant gas bubble probably formed deep within the star, triggering and altering its pulsation rhythm. The JWST's observations have provided a closer look at the material ejected by Betelgeuse, unveiling intricate structures surrounded by gas and dust. These findings suggest that Betelgeuse may be nearing the final stages of its life cycle, offering an unheard-of glimpse into the life of massive stars. While scientists predict that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its erratic behavior suggests the timeline may be significantly shorter. The astronomical community is racing to capture every detail of this cosmic spectacle prior to its dramatic climax, ensuring humanity doesn't miss this rare event. In late 2023, the JWST, with its unparalleled observational features, centered on Betelgeuse and uncovered startling new phenomena. Scientists discovered that the star, already in a state of instability due to its massive surface mass ejection, had suffered an immediate internal collapse. These significant indicators of collapse included changes in its core dynamics, which changed how nuclear fusion reactions happened. Astronomers observed dramatic fluctuations in Betelgeuse's expansion cycles before the collapse, with the star's surface expanding and contracting steadily over 400 days. Afterward, this rhythm was suddenly reduced to just 200 days, signaling a massive disruption in the star's internal structure. These irregularities served as a cosmic heartbeat, signaling that Betelgeuse might be approaching the end of its life as a red supergiant. Simulations conducted by astrophysicists revealed that the star's core is becoming more unstable as it fuses heavier substances. When stars reach this point, they start making iron, a process that denotes the final phase before the collapse. Unlike other components, when fused, iron does not produce any energy, causing a buildup of mass that eventually leads to the collapse of the core. Betelgeuse's recent behavior has sparked heated debates among astronomers regarding the timeline for its supernova. While some argue that the explosion could occur within the next few centuries, others believe it could still be thousands of years away. What is clear, however, is that Betelgeuse's time as a red supergiant is drawing to a close. A supernova is imminent. Is a surge in neutrino activity, tiny subatomic particles that break away from a star's core moments before it collapses? Scientists are keeping a close eye on Betelgeuse in case of sudden increases in neutrino activity, and the tools in its vicinity around the world are on high alert to detect this fleeting signal, which could provide humanity with its first real-time warning of a supernova that is about to occur. Betelgeuse's supernova will be an awe-inspiring cosmic event that can be seen even during the day. Scientists assure us that it poses no danger to Earth. However, its brightness could be comparable to that of a moon, casting strange shadows and, for weeks, illuminating the night sky. Not only will this event captivate stargazers, but it will also offer an unparalleled opportunity for researchers to examine stellar death in real time. The story of Betelgeuse reminds us that there are still many mysteries in the universe waiting to be found. This huge star, which has captivated mankind for centuries, continues to challenge our understanding of stellar evolution and cosmic dynamics. As Betelgeuse surprises us with its dimming mass ejections and unpredictable behavior, it serves as a reminder of how much more there is for us to learn. That it has the potential to explode offers scientists an extraordinary opportunity to study the life cycle of massive stars firsthand. Understanding these processes goes beyond just dismantling the fate of one star. It's about unlocking the mechanisms that shape vital matter, entering the universe from galaxies, elements, and even making life possible. This knowledge expands our understanding of the universe's past and our position in it. It contains the study tools we use. Betelgeuse, from ground-based telescopes, such as the Very Large Telescope, to cutting-edge instruments like the James Webb Space Telescope, has opened up brand-new doors into the universe that past generations could only dream of. These technologies enable us to conduct simulations, study stellar dynamics, and peer billions of years into the past, all to gain a deeper comprehension of the very fabric of reality. For scientists like Neil deGrasse Tyson, discoveries like these bring a sense of urgency and excitement. They push the boundaries of human knowledge and challenge us to keep exploring the cosmos. The next time you look up at Orion's belt, remember that one of those points of light tells the story of a star on the brink of its destiny. What do you think will occur to Betelgeuse? Are we witnessing the final moments of a star about to burst into flames, or another phase in its mysterious life cycle? Contribute your ideas and join the discussion of one of the most intriguing stars in the universe. Don't forget to like, subscribe, and turn on notifications for more stories about the cosmos that will leave you in awe. Until next time, keep your eyes on the skies. As we keep an eye on Betelgeuse and its behavior, it becomes clear that this star is not just a fleeting spectacle in the night sky. Its unusual activity is supplying astronomers with uncommon opportunities to study the intricate processes that govern the evolution of massive stars. Every shift in brightness, every surface mass ejection, and every sudden change in pulsation patterns brings us one step closer to comprehending the mechanics of stellar life cycles. One of the most intriguing features of Betelgeuse's evolution is the fact that it's in a relatively rare phase of its life cycle. As a red supergiant, Betelgeuse is nearing the end of its life, but its path to supernova isn't as straightforward as it might seem. The exact causes of the irregularities in its behavior are still being debated by scientists. At the same time, the surface mass ejection is one of the most dramatic events observed so far. It could be just the beginning of a more complex series of changes that lead to the star's eventual explosion. How fascinating is Betelgeuse? A supernova may have some answers to some of the most fundamental questions in astronomy. The sudden death of a star like Betelgeuse holds the potential to spill the beans on the nature of dark matter, the expansion of the universe, and the intricate processes that resulted in the birth of new stars and planets. These revelations could help scientists refine current models of the cosmos and gain a deeper understanding of the universe's evolution over billions of years. According to the research, Betelgeuse is a component of a broader effort by the global community of astronomers to comprehend the study of the life cycles of massive stars. Scientists can use stars like Betelgeuse to learn about stellar evolution's final stages, which are well known for being difficult to observe in real time. Most stars die in ways that are incredibly distant and hard to witness. So when a star like Betelgeuse begins to show indications of its last explosion, it provides an outstanding chance to observe this close-up cosmic process. One of the questions that remains unresolved is how long before Betelgeuse finally reaches the supernova stage. The timeline for the star's demise is still unclear, and scientists are always changing their predictions based on new data. Some astronomers consider that Betelgeuse could explode sooner than expected, while others think it could take thousands of years before the supernova occurs. Regardless of when it happens, the giddy anticipation surrounding the star's eventual explosion can still be felt. For now, researchers continue to monitor Betelgeuse closely, using a variety of sophisticated instruments to capture all of the information they can, from ground-based observatories like the VLT to space telescopes like the JWST. Scientists are utilizing the latest technology that allows for a deeper look at this enormous star. The data they collect will help refine our understanding of the evolution of stars and offer insights into the universe's driving forces itself. In the narrative of Betelgeuse, it serves as a potent reminder of the vastness and complexity of the cosmos. There are many moving stars in the universe going through incredible transformations, but few provide a clearer look at the final stages of a star's life as Betelgeuse performs. Its upcoming supernova will be a significant event that may assist scientists in answering some of the most profound questions about the nature of stars, galaxies, and the universe in its entirety. Even if we don't yet understand precisely when Betelgeuse will explode, one thing is certain: its eventual death will be a significant moment in the investigation of stellar evolution. For astronomers and scientists, it is a worldwide event that will offer numerous opportunities for advancement and discovery in our understanding of the cosmos. And for the rest of us, it will be a reminder of the incredible beauty and mystery of the universe we reside in.